Akan memberikan pembicaraan tentang elektromagnetik ya, dia lain dari sesi-sesi yang sebelumnya. Mungkin ada bapak-bapak, ibu pernah, yang pasti itu Pak Damora sebagai narasumber juga di sesi DF itu. Ini merupakan sesi dengan warna yang baru. Mungkin saya akan memulai saja karena waktunya juga udah 6 menit lewat jam 12. Saya akan share screen saya. Untuk menampilkan slide saya berupa pengenalan tentang sesi ini. Oke, boleh dicek Mas Jatmiko apakah tampilannya sudah baik?
Oke Pak, layar sudah memunculkan tampilan dari
Oke, saya mulai aja. Selamat siang Bapak-Bapak, Ibu-Ibu, dan para profesional, para mahasiswa-mahasiswi. Nama saya Edi Rusli dari Optimax. Selamat datang di sesi discussion forum 6 kita yang berjudul Modeling Low and High Frequency Electromagnetics with Ansys Maxwell dan HFSS. Acara ini diadakan oleh Optimax bekerja sama dengan CADFM. Oke, selanjutnya sedikit himbauan dulu, ini penting sekali, tentang COVID-19 ya, pandemi yang kita alami sekarang ini. Menurut saya keadaan sekarang ini cukup genting ya, di mana gelombang kedua itu udah mulai terasa impact-nya itu. Di Jakarta dan Pulau Jawa itu sudah ketar-ketir menghadapi penuhnya pasien di rumah sakit. Jadi bagi kita semua mohon untuk menerapkan yang namanya 3M ya, tetap ya, masker, cuci tangan, jaga jarak. Dan kalau bisa dikali 2 menjadi 6M, kita juga dihimbau untuk mengurangi yang namanya mobilitas, mengikuti anjuran pemerintah, menghindari keramaian, dan juga menghindari makan bersama. Makan bersama itu kita terpaksa harus membuka masker kan. Nah, kalau di gambar ini kita bisa lihat ada suasana di mana seseorang itu tanpa menggunakan masker di suatu lingkungan yang kelihatan seperti kantor ya. Terus ada juga yang memakai masker. Ini merupakan simulasi yang kita lakukan tahun lalu. Sekedar mencari tahu penyebaran aerosol dan juga droplets ya. Aerosol itu dia kan bisa terbang di udara. Jadi simulasi ini kita lakukan dengan menggunakan Ansys Maxwell. Nah, kalau ini akan menunjukkan perbedaan jumlah dari aerosol tersebut untuk seseorang yang bersin dengan dan tanpa masker. Jadi untuk tahu lebih mendalam silakan check it out di salah satu channel sosial media kita, kalau nggak salah YouTube gitu, videonya ada, cuma singkat beberapa menit doang. Jadi bisa kita lihat di sini dropletnya itu akan banyak sekali ya. Untuk yang tanpa masker, dengan masker itu bisa direduksi resiko penularan sampai 98,5%. Makanya saya tekankan pentingnya itu untuk menggunakan masker. Oke, sekedar pengenalan tentang company kita. Kita merupakan sebuah perusahaan namanya Optimax Terima Teknik yang bergerak di bidang pemasaran software engineering. Kita juga melakukan jasa konsultasi project dan pelatihan, juga technical support untuk software engineering ya, terutama Ansys software, karena kita itu merupakan distributor resmi. Jadi saya perlu tekankan di sini, kita itu bersifat resmi atau official, bukan reseller, juga bukan yang tidak resmi, yang menggunakan software bajakan, tidak ya. Nah, kita mempunyai kompetensi, ya harus ya, karena kita merupakan channel partner, kita harus bisa untuk melakukan demonstrasi, melakukan simulasi, intinya bagaimana cara menggunakan produk dan mendapatkan faedah dari penggunaan produk tersebut untuk bidang-bidang engineering seperti desain, mechanical, chemical, fluid, electrical, optical, maupun teknologi tinggi sekarang ini seperti IoT dan digital twin. Customer kita cukup beragam, tapi didominasi oleh sivitas akademia yang sampai sekarang ini udah kita rangkul cukup banyak ya, mungkin lebih dari 20, termasuk ITB, UGM, ITS, Trisakti, Udayana, USU, UNY, UPM, Unila, Polinema, dan lain sebagainya. Terus ada juga beberapa customer komersial kita seperti Andala Valvo, Energia, dan lain-lain. Oke, nah untuk discussion forum itu kita rutin mengadakan. Jadi nanti boleh menanti kabar dari kita untuk sesi selanjutnya karena data udah ada di kita akan mengirim pemberitahuan untuk sesi selanjutnya dari peserta hari ini kan. Discussion forum sebelumnya itu kita banyak berkutat di bidang struktur dan CFD dan juga desain yang di discussion forum 5, dan untuk kali pertama discussion forum 6 ini kita memfokuskan ke bidang Electromagnetics dengan menghadirkan 2 pakar dari CADFM India ya. Jadi mereka ini akan memberikan insight yang berbeda untuk bidang ini. Sedikit tentang peserta webinar hari ini merupakan data yang kita dapat dari registrasi Bapak, Ibu-ibu, saudara-saudari semua, di mana kita menanyakan apakah saudara sudah pernah menggunakan software Ansys. Jawabannya itu 54% itu sudah, jadi ini bagus sekali. Jadi kita bisa mengerti dan menyimak lebih dalam tentang software Ansys nanti di sesi presentasi. Terus untuk profil peserta juga beragam sekali. Dan ada yang paling banyak itu dari alumni dan mahasiswa ya, kalau alumni mungkin cukup kecil persentasinya. Terus ada banyak juga dari dosen, tenaga pendidik, manajer, researcher. Jadi banyak sekali beragam-ragam peserta kali ini dari berbagai macam background. Terima kasih atas kehadiran saudara-saudari, bapak, ibu semua. Semoga sesi ini akan bermanfaat. Sekarang saya mengenalkan narasumber pertama, Mr. Hara Prasad Sivala. Beliau ini mempunyai master di Power and Industrial Drives ya, Association dengan CADFM India sebagai Application Engineer di bidangnya itu di Electromagnetic untuk low frequency. Jadi keahliannya itu di area desain dan analisis kontrol untuk electromagnetics devices seperti mesin atau motor listrik, aktuator, dan sensor. Nah, untuk narasumber kedua ini jauh lebih berwarna ya, keahlian dan pengalamannya itu udah 5 tahun di EM Simulation Tools, hal-hal seperti SI, PI, EMI, EMC, EMI, EMC itu electromagnetic interference dan compatibility ya, untuk antena, RF system, baik itu untuk mendesain atau untuk mengetes hardware-nya itu, dan juga untuk measurement instruments. Kompetensinya juga meliputi berbagai macam electromagnetic tools seperti 3D EM, ESL, 3D planar, 2D EM, 2D planar, dan lain sebagainya. Mempunyai pengalaman dan keterampilan di wireless technology dan sistem seperti GSM, CDMA, LTE, 5G, radar. Jadi cukup banyak sekali pengalaman dan keahlian beliau ini. Beliau juga udah mengikuti banyak training dan project di Indian Defense DRDO Center, di singkatan-singkatan dari LRDE, DER, dan lain itu mungkin bisa ditanyakan langsung ke Mr. Salma sendiri, karena saya sendiri juga kurang tahu ya. Dan yang terakhir itu Mr. Salma juga sangat aktif untuk menulis makalah-makalah ilmiah di conference internasional maupun jurnal yang berasosiasi dengan IEEE dan Springer untuk teknologi baru seperti 5G, MIMO, antena, adaptive radars. Oke. Jadi format acara ini langsung akan saya pindahkan ke presentasi pertama selama 25 menit, diikuti presentasi kedua 25 menit lagi untuk high frequency. Setelah itu baru kita adakan sesi Q&A selama 10 menit. Dan terakhir 5 menit untuk mengisi daftar kehadiran. Daftar kehadiran nanti terakhir akan saya tampilkan lagi supaya Bapak, Ibu, Saudara-saudari bisa men-scan QR code ini untuk mengisi kehadiran supaya itu kita bisa memberikan yang namanya sertifikat kehadiran untuk acara ini. Terakhir, sosial media kita ada 3 di YouTube, Instagram, dan LinkedIn. Silakan di check it out. Dan sekian dari saya. Selamat menyimak dan menikmati sesi-sesi selanjutnya. Terima kasih. Selamat siang. Okay, maybe we can start with the first session for low frequency or even high frequency. 25 minutes has been allocated for your session. Mr. Sivala, thank you.
Thank you, Eddie. Thanks for the nice introduction.
Thank you.
Let me start sharing my screen. I hope you guys are able to see my screen. Could you please confirm that?
Yes, it's all good. Yes, go ahead. Thank you.
Okay, thank you. So just let me know in case if my audio or anything is not proper, then I will try to correct myself. Okay.
No problems. Thank you.
Yeah, thank you, Eddie. So hi, good morning to everyone. Myself, Haraprasad Sivala, and I'm working as an application engineer in CADFM. And basically, I will take care about this low frequency part. Okay. So before going to the technicalities of Ansys Maxwell, I will give you a couple of slides on what Ansys can offer you on the overall platform and what exactly Ansys is. In a nutshell, just I will take a couple of minutes on that. Okay. So just I will tell you, Ansys I can say is the market leader in the simulation platform. The reason is very simple. It's purely into the simulation. We don't want, there is nothing into the CAD platform or anything. It is completely concentrated into the simulation platform. And the beauty is it has the footprints in each and every major physics. You can name with the structures, it might be started. Then after they have acquired a lot of solutions like fluids or electromagnetics and embeddeds. Or recently, they are also acquired this couple of simulation softwares on the optical side. So you can understand that Ansys has footprint in each and every physics. The beauty is it's not that we are into every physics. The major physicists can talk to each other on a single platform. So that's the beauty of Ansys. And we can integrate those things in a single platform. So with this, just I will make one sentence that Ansys can offer you, the best of breed simulations across the major physics, and it can be a one-stop solution for your challenges as well. So this is just a one slide where Ansys can offer you, if anyone is interested on this electric vehicle market, Ansys can offer you a 360 degrees platform where you can see the major components might be the battery or a traction motors or a powertronics or a system engineering. So Ansys has a solutions for all these major components to address the different challenges from the different physics it might be or different applications. So today's topic would be mostly on this Ansys Maxwell capabilities and what are the applications it can handle. So if you talk about Ansys Maxwell, I can say this would be the high fidelity, the generic electromagnetic software for the low frequency. So when I say low frequency, basically, before jumping into the Ansys Maxwell technicalities, just I will give you a brief difference between what exactly the low frequency and what exactly the high frequency. So in Ansys platform itself, in the electronics itself, we have two things. One is the low frequency and another one is the high frequency. So low frequency means the frequency range where that particular application is working, okay, which decides whether it belongs to the low frequency applications or high frequency applications. So in our case, basically the frequency will start from certain zero frequency to a couple of megahertz. I can say there is no hard stop, but it would be somewhere around 40 or 50 megahertz. Okay, you can go up to that. And at the same time, there is, the high frequency will start from certain kilohertz to gigahertz and more than that. Of course, there is a band, band where the frequencies can overlap, and it always depends. Okay, which particular application or exactly which tool is going to suitable for that particular application and for that particular analysis part. Okay, according to that, we will choose whether we can go with Ansys low frequency solvers or a high frequency solvers. Okay, so that is the basic difference. Then if you can look into the low frequency, okay, here is the product, the name called Ansys Maxwell. So basically, Ansys Maxwell is a generic high fidelity electromagnetic solver. The name mentioned generic means you can take any component, any electromechanical components or any electromagnetic components. Ansys Maxwell can work around that. So, sorry. So basically, it is a 2D as well as a 3D high fidelity FEA based solver. Okay, so it will uses the finite element method to solve that particular applications. Okay, when I say finite element method, it will discretize the geometry into a particular sections. Then that will be analyzed as for the field gradients and all. So here basically you can see this. To discretize those components, it will uses the meshing technologies, and Ansys Maxwell has its own meshing technologies. Okay, it has both automatic meshing as well as the manual control mesh. I will talk those things on the later slides. And apart from these things, it can offer you the complete set of electrical and magnetic fields. Okay, so basically the how it can address those things. Okay, it is basically built on 4 basic Maxwell equations. Okay, where you can take the Faraday's and the Gauss law for both electricity and magnetism, and as well as this Ampere's law also. Okay, so by using those 4 basic Maxwell equations, okay, they have implemented this Ansys solvers, Ansys Maxwell solver basically. Okay, so which will help us to understand the magnetic as well as the electrical phenomena of these particular applications. And it can also do a couple of optimizations. Okay, it has an optimizer solutions inside, which will help us to do some parametric based optimization things. And if you talk about the post processing things, are you can call it as the outcome which you are getting out of these things is basically, if you take any components, like it might be a actuator or it might be a transformers or a motors or a generators. Okay, it can give you the all electromagnetic outputs, like the forces it might be for a linear motions, or a torque if it is a rotational motions, or a losses on this particular copper components or steel materials it might be. Or if you want to check the efficiency of a particular component, yes, you can able to do those things. Okay, so all these things can be able to give us in this Ansys Maxwell solvers. And it has its own set of solvers. Okay, it has some certain template based solvers. You can see RM expert and PE expert. Okay, which I'm going to talk in the coming slides. As well as the beauty with this Ansys Maxwell solver is it will take some reduced order model technology, which is nothing but you can do the field calculations here, and this field component, okay, this physics based component can be integrated to your system level solvers, where you can control, where you can use this physics based models without losing the accuracy. That's what we call it as a reduced order model technology. On the other way side, you can also use this co-simulation models. Means this physics-based model can be work on the background, and along with that, you can directly do the co-simulation from your system solvers. And the beauty with this Ansys Maxwell solver is it can talk to the other physics. As I mentioned in the initial slide, you can couple with a mechanical as well as CFD to understand the structural behavior as well as the thermal behavior of the particular applications. And you can see the common applications. Anyway, I'm going to talk these things on the coming slides, but this is just a brief here. So as I mentioned in the previous slide, we have we have a couple of advantages in the Ansys Maxwell solver itself. Once you go with that particular licensing, you will also get this basic Simplorer as well as RM expert and PE expert. These are, I can say, the dedicated 1D platforms basically. So the Simplorer is a kind of system level solvers, or a multi-domain, I can say the multi-domain system level solvers, where you can integrate the physics based models into these particular solvers, and it has already template based, certain, template based for this electrical or a magnetic or, the mechanical or a fluids or anything you can take it as. Okay. It has a already defined models for us, a 1D models. You can just drag and drop it and you can able to work with that particular things. And the next one is this RM expert, which is nothing but rotating machinery expert. So if somebody is interested on this electrical motors or a generators, they can able to work directly with this analytical solver in the initial level calculations, and which is integrated inside Ansys Maxwell. So there is a direct coupling between this RM expert as well as the Maxwell. Once you set up the model in RM expert, then this can be directly create an FEA model for us. Okay. And even the P expert is same, okay, which is nothing but the power electronic expert, which will give us an idea on this electronic transformers or any kind of a structure, toroidal structures, it might be, are inductors. So all those things can be solved here. And this is also a kind of 1D platform, and which can be integrated to the Ansys Maxwell for high fidelity FEA simulations. And once we're done with this basic geometry setup or anything, then you can directly go for this material modeling. Obviously, when you are dealing with this high fidelity solvers, the major important thing is like, we need to concentrate on this material modeling. Okay. How accurately, if you model the materials, then that much accurately we can able to get the particular application performance. So that's where Ansys, I can say, a step forward compared with the other solvers. You can see here, you can able to model the either a linear or a non-linear materials. Okay, if you take isotropic or anisotropic properties, which are changing the material properties with respect to the directions, or you can check the, the temperature dependent materials also. Means we can also create couple of models with the temperature dependent materials, as well as it can also consider this hysteresis modeling, where you can consider the minor loops also. And if you want to properly model the core losses, we have a temperature dependent core losses can be modeled here. And if you want to check the magnetostriction, or inversion magnetostriction, where if you want to check the mechanical stress on the magnetic components, so that kind of advanced material modeling can be done in Ansys Maxwell solvers. And the next part would be obviously the meshing part, because we are dealing with the finite element mesh. Okay, so here obviously, as an electromagnetic engineer, we are not pretty sure on the finite element methods. Then, but still, Ansys can offer you the techniques called this auto adaptive meshing technology. Even if you are not familiar with the finite element method, it will offer you the automatic meshing. You can see this. Once you define the number of iterations, automatically it will define the proper and accurate mesh for us to reach the finer finer results. In case still, if you are not satisfied with this auto adaptive meshing technology, we can use the manual control mesh, whether it might be the first order or second order elements. You can able to control this manual mesh, and you can able to reach the high-end accurate mesh elements. Okay, you can check there are a different kind of manual control mesh techniques were available. We can use these things to properly, get the dense mesh on our applications. And the next part is obviously when you are dealing with this high fidelity solvers, the time is a major concern for the simulations, because it is dealing with the finite element method. Then obviously time is a major concern. So, so to speed up the simulations, Ansys Maxwell has a certain solutions like this TDM and DDM methodologies, where it will do the multi-threading. I can say you can use the multiple cores to run the simulations, as well as you can run your simulation points simultaneously. So this will reduce the amount of simulation time which you're spending on that particular simulation running, as well as it can increase the productivity of that. And with this, you can able to properly model the accurate ROMs. Okay, here is a test case. You can see basically in the initial cases, it took somewhere around 15 days, but after scaling up with respect to this HP TDM methodologies and all, by using this HPC performances, it can reduce it to 5 hours. You can see how drastic change has implemented here. But of course, it need a finer number of cores to reach to this position, obviously. Okay. So far we discussed completely on the only electromagnetic side, but we haven't discussed the things on this multi-physics environment. So what if some challenges comes from the multi-physics environment, which are related or which are combined with the electromagnetic solvers? So how Ansys can handle these problems? So here is the solution. You can see initially, for example, if you take a motor, you want to check the vibration behavior of the motor, then you can see here, I have simulated the motor in electromagnetic solver called Ansys Maxwell, and that has integrated in our platform called Ansys Workbench. And these, these solutions, whatever you are getting, the electromagnetic solver solutions, that will be directly coupled to the mechanical solvers. You can see here, and we are representing, or we are extracting the loads or the electromagnetic forces on the stator tooth will be directly mapped onto the mechanical to check the vibration behavior and to check the structural deformation on the stator tooth. So the problem here is either you can run at a single RPM, or when you are running at a multiple RPMs also can able to simulate here. So that is the beauty of Ansys and all these platforms. Okay, so either the mechanical and the structural part, okay, or on the acoustic part, everything can be integrated in a single GUI, and it is a just drag and drop methodology. We no need to export or import a files or anything. Okay, it is simple drag and drop methodology. So here you can see this simple approach, whatever I have discussed previously. This is an electromagnetic simulations, electrical, motor simulations, where we are computing this law, the forces, and these forces are exported here. And these are on the time, on the mechanical side, where you can see the vibrations, and these vibrations has given as an input to the acoustics. And here finally you can able to hear the noise also. And the other way around is, in case if somebody is facing the challenges from the thermal side, then we can choose the same platform, Ansys Workbench, to integrate the electromagnetic solver with the fluent solvers, where you can directly drag and drop methodology. You can transfer the losses which are computed in the electromagnetic windings, it might be, or on the a stator and a rotor profiles. Okay, so that will give us an idea on the degradation in the material. You can see here, when you are doing this two-way coupling, you can able to understand what is the real-time scenarios and how exactly the real-time things are happening here. So with this, you can able to get, there is a 16% drop in the predicted performance. Okay. So if you are only doing the electromagnetic simulations, you can meet your requirements, but that is not the real-time scenarios. Okay. To model these real-time scenarios, obviously you need to do this multi-physics environment. So that is basically on the capability side. I can just, there is a couple of slides on this capability, applications wise. I will just a quick manner. Okay, you can see this is an environment for motors, where there is a design phase, the advanced phase of modeling. And once you're done with this, the next part would be the coupled analysis, as we discussed in the previous slides, the mechanical vibrations it might be, the temperature scenario. And finally, this motor can be integrated into the system level solvers to check how good is the motor performing in the complete system. Okay, here is the electrical machines, and there is a couple of things you can do, either initial phase analytical approaches or a detailed FEA approaches. If you want to do the multi-physics environment, or you want to check the efficiency maps or anything, or if you want to do the complete system level analysis, or if you want to do the demagnetization effects. So all those things can be addressed here. And even for the transformers also, if you take transformer or anything, that can be also solved using the Ansys Maxwell solvers. And if somebody is interested on this wireless power charging, okay, that can be simulated either for inductive or for, sorry, or for this resonance type inductive, or for this microwave type, wireless power transfer. Of course, for the microwave type power transfer can be handled in the high frequency side. But for the induction type, yes, we can able to simulate in the low frequency solvers called Ansys Maxwell. And even for actuators also, if somebody is interested on the actuators simulations, okay, because that is also an electromechanical component where you can predict the linear motion. You can able to see what is the stroke position with respect to the distance, and what is the force acting on that particular plunger it might be, and when you are exciting the coil, how much is the force acting on the plunger, does it fine enough to overcome the spring force or not. So all these kind of simulations can be handled using this electromagnetic, electromagnetic solvers. And if you are interested on the bus bar simulations, okay, to check the losses, it means the bus bars are insulation. If you want to check it, the dielectric capabilities of the insulation, as well as the structural deformations are on the thermal performance of those bus bars or cables. Okay, so all those things can be simulated using Ansys Maxwell solvers. And if somebody is interested on the sensors, okay, the electromagnetic sensors, you can call it as the variable reluctance sensors, which you can find it in uh, the bike wheels basically. And hall sensors, you can see the eddy current flow sensors, where where you are using these things in the tube, the boiler tubes it might be, to check the porosity and all. Okay, so those are the couple of applications, and here is an case study on this traction motors. You can see here basically, this is a competitor for Tesla on the EV side. They have used our solution to implement the electrical motors from a design phase to the complete system level solvers. And you can see the comments from the from that lucid guys, which we can share with you also. Okay, these case studies. So with this, I would like to stop. If anyone has any queries, you can feel free to ask.
Okay, thank you, Mr. Shivala, for your informative and insightful presentation. I think we have seen how great and how capable this Ansys Maxwell is for low frequency applications. Okay, just to save time, we would like to move on to the high frequency presentation, HFSS, by Mr. Tama. Okay, and we'll just do the Q&A at the end. So para peserta, kalau ada pertanyaan mohon dituliskan dulu di chat room atau di kertas dulu, nanti bisa ditanyakan pada setelah sesi yang kedua ini. Oke. Stage is yours, Mr. Sama. Thank you.
Yeah, thanks. So, Hara, can you stop sharing your screen? I'm not able to share. Yeah, now I can.
Yes, I did hand over to you.
Thanks. So, is my screen visible?
Yep, it's visible.
Yes.
Yeah. So, hello everyone. Myself, Safal Sharma. So, I work as a technology specialist in CAD/FEM, and this session mostly I'll be talking on HFSS, which is similar to Maxwell, which Hara recently spoke, but in terms of frequency, it is a high frequency solver. But generally, it is a electromagnetic solver only. So overview, like in high frequency, so Ansys HFSS, or rather Ansys has a solution can be even used for PCB and package kind of simulation, and then EMI EMC simulation of PCB packages. A complete system level EMI EMC simulation also can be done. In terms of the simulation technique, we have both circuit as well as 3D or 2D electromagnetic simulation, GUI or solver. So even as per the application, as per the requirement, even EM co-simulation, which is EM and circuit simulation, also can be performed. So the beauty of Ansys is definitely, yes, it is a multi-physics platform. So where you can do electromagnetic studies, you can do thermal studies as well as structural studies also. Meaning whatever losses are coming from electronics component, or rather electromagnetic solver, those losses can be coupled to study the thermal behavior, and those thermal losses can be used and can be coupled to study the structural behavior also. So it is a complete multi-physics platform. So in terms of transmission line basics, so at low frequency, mostly, like AC signal or, those kind of low frequency signals, the transmission is not a problem. So the instantaneous voltage and current values, remains the same across, all the position of a cable or any transmission medium. The instantaneous current and voltage value remains the same. But once we move up in the frequency, once we increase our frequency, then the instantaneous current and voltage value changes. That causes the impedance to change. So we call it characteristic impedance. So whenever characteristic impedance changes, the maximum power won't be transformed, right? The maximum power transfer theorem tells that the source and the load impedance has to be same. So if it is not same, there will be losses. So that's why at high frequency, those component has to be properly designed so that the losses, this transmission losses, has to be kept as less as possible. If it is more, then there would be, a larger problem. And mostly we study this kind of losses in a frequency domain, not time domain. But in time domain also, some simulations can be done, but majorly this kind of losses we study in time domain. So this is just one, example how the losses happens in high frequency device. Even it is applicable even for low frequency device also. So you can consider, the any device, or we also call it DUT, device under test, to be a simple lens, right? So consider this one to be a simple lens. So any light, whenever any light is incident on a lens, what will happen to that light? Some light would be reflected back, some light would be refracted or transmitted within, across the lens, right? Across the medium. So same thing can be replicated in electromagnetics also. So instead of lens, it can be, it can be antenna, it can be any EM devices. Same thing happens. So some energy would be reflected, some energy would be transmitted. And when we divide the incident, reflected, and transmitted, we can extract all those parameters like the return loss. If it is a filter, it will be a loss. If it is an amplifier, we can see the gain of an amplifier. We can see the group delay. So all those studies can be done. And in terms of solver, so definitely in order to study all these things, we need some solver, right? We have to solve some equations in order to capture the electric and magnetic field. So that equations, we call it Maxwell equation. So our tool HFSS solves Maxwell equation majorly using differential form. That's why it is known as FEM method. But in Ansys, anyways, I'll talk that in the upcoming slide. We have both FEM, MOM method. So depending on the application, we have 3D solver as well as 2D solver. So if it is only a PCB kind of application, 2D solver is fine enough. If it is a 3D cable, 3D connector kind of application, then we need to make use of 3D solver. The difference is in 2D solver, it only does the surface meshing. In 3D solver, the entire volume would be meshed. So HFSS is a full wave 3D electromagnetic solver. So when I tell full wave, it computes electric field in all the vectors. So it will compute Ex, Ey as well as Ez. Similarly, for magnetic field, it will compute Hx, Hy, and Hz. So that's why it is known as full wave 3D electromagnetic field simulator. Okay, and no assumptions are made. Like it fully, solves all the Maxwell equation, all the coupling between the Maxwell equations without making any assumptions. That's why it is a actual Maxwell equation solver. And you can see here the electromagnetic field can be studied from a body. So here it is a car. The field is coming out from an antenna of a car, and there is a human body. So how the human body is receiving the field from a car, this kind of studies also can be done. And any 3D model can be imported in HFSS. So there is no restriction. Any arbitrary 3D model can be imported in HFSS. And yes, it solves for electric field. Once we get the electric field, it will use the electric field data to obtain the magnetic field. And then once the electric and magnetic field is obtained, it will calculate the surface current, it will calculate and it will extract the S, Y, Z parameters. So this is the common CEM approach. You will be importing a structure, dividing the structure into small segments. and then we get the result. But the kind of technique we have in Ansys is like, as you can see here, it is a band pass filter. So the each mesh is a tetrahedral, and in all the vertices, vertices, midpoints, the electric and magnetic field would be obtained. Now the beauty of Ansys HFSS is that it has something known as automated adaptive mesh refinement process. So meaning you don't need to worry much about mesh. Okay, as per the requirement, as per the frequency, software will automatically give you the best mesh. So it won't do over meshing also, it won't do under meshing also, it will generate the optimal mesh. So it is a iterative process. So step by step, in every pass it will fine tune the mesh. So wherever the error is more in that particular area, it will increase number of mesh, number of tetrahedral. And as you can see, the animation, if I play, then at every pass, the number of mesh is increased here. And when number of mesh is increased, automatically it is increasing the accuracy of the simulation. So that's why the accuracy is very high for this kind of electromagnetic simulations using HFSS. And the key output parameter is S parameters. So not only S, but you can obtain S, Y as well as Z parameters also. So once we solve the electromagnetic problem, then we can use those solved data to extract S, Y, Z parameters. So as I told, as parameter already I have explained in terms of length. So it is a ratioed measurement. So input by output. If I know the input and if I know the output value, and if I tend to do the ratio between input and output, I can calculate the losses like gain. All those things can be calculated. So in terms of solver technology, so FEM, finite element method, is the heart and core solver. But depending on the application, we have integral equation solver also. So commonly this method is known as MOM method, and we have physics based solver also. So if somebody is working on a very large platform, then you can use this physical optics solver also. It uses the diffraction and refraction concepts. And we have transient solver also, and we have 1D or circuit solver also. So it can do linear, it can do non-linear, as well as transient circuit simulation. And we have optimetrics also. If somebody wants to do optimization kind of studies and all, we have optimization capabilities also. So some of the application of HFSS are so antenna array, antenna array, then platform integration. So we also call it antenna platform study. The microwave component like filter, waveguide connectors can be simulated, designed. Then RFIC and MFIC board. Then in aerospace and defense, in ADAS systems it can be used, in IoT and RFID, in high-speed interconnects, and similarly for EMI EMC also it can be used. So I'll try to talk about the few applications in the upcoming slides. This is just the HFSS GUI. So depending on the application, different GUIs are there. And this is just the HFSS GUI. So I mean, in this you can see this is the 3D model tree window, and in top side toolbar there is a property window, message bar. So once if somebody starts using the tool, then this becomes more and more familiar, all these GUIs and all. And in terms of workflow, so doesn't matter whatever application you are working, this is the generic workflow. You will either design your structure or import your structure, and then you have to assign the material, like permittivity, permeability, or what kind of materials you want to use. We have a dedicated material library that can be used. Then the boundary has to be defined, boundary conditions, like in which area you want to mesh, you can define those areas. Then if it is antenna kind of application, you have to define the antenna ports. We also call it antenna excitation. And then simulation setup, it is nothing but I'm telling the software from which frequency to which frequency I want to solve, and then it will do the meshing part. After I give the frequency and all, it will And after I run the simulation, it will do the remeshing part. It will do generate the fine mesh. Once fine mesh is generated, it will give you the result. And result would be, as you can see, electromagnetic field, 3D electromagnetic field, even S parameter, Y parameter, Z parameters, far field, near fields, all this can be obtained. In terms of antenna, so we have something known as antenna toolkit. So this is a so there is a dedicated toolkit for antenna. We also call it antenna synthesis. So there is a 60 plus. Hello. So there is a 60 plus predefined antenna topologies. You just need to give the frequency of interest. Tool will automatically generate the antenna, and it will also give the 3D model of the antenna, which is a parameterized model. That means you can, after 3D model is created, you can do the changes in terms of the geometries and all. And then once you solve, you'll get the simulated result. Like for an antenna, as you can see, it is S11 return loss of the antenna and the far field of an antenna, like gain, all those things, beam width, all those things also can be calculated. So there is a real-time antenna tuning. So if somebody wants to change the width and height of the antenna patches and all, then those can be done, and you can see the variation in return loss. We also call it real-time antenna tuning. If somebody is working on a phased array kind of application, then normally when I talk about phased array, then phased array means the number of antennas are more. That means there might be 100, 200, 300, 500 number of antennas, right, in phased array. So solving 500 number of antennas using our common method becomes very time consuming, right, and it will take longer time. So that's why there is a dedicated method which is known as the finite array domain decomposition method. So this method makes sure that the accuracy is not compromised, and it will generate the high fidelity result in a lesser time. So how this method works, it will, so as I said, in antenna array there will be multiple number of antennas. So it will only mesh the single antenna here. It will generate the mesh for a single antenna, and same mesh it will use for the entire antenna array, and it will give the result. So doing this mesh reuse, or instead of meshing everything, if I use the same mesh, I'm saving the time. So that's why this methods becomes very helpful if somebody is working on an larger antenna array kind of application. And you can see the field across the array, like electromagnetic field can be viewed. And sometimes people will be working on a different components also, RF components like amplifier, waveguide, power amplifier. Everything can be designed and simulated in Ansys, and everything can be brought into our circuit tool, 1D tool. And then if somebody is interested, they can also do the system level simulation also, like when I put everything together, how it works. If it is an antenna array kind of application where there is a beam forming network and all, then you can create your beam forming network, and then you can just do the antenna shifting, phase shifting and all. Then you can check how good and how bad your antenna is. This is one example of the entire antenna system. So in this is the actual 3D model. So there is the antenna, there is the beam forming network also. As you can see, everything has been simulated in Ansys. So you can do this in entirely in 3D also, or else you can just simulate the antenna, bring it in circuit, and then design everything in circuit, and you can do EM core simulation also. In terms of circuit simulation, as I told, we have DC, we have transient, we have linear as well as non-linear simulations also, like harmonic balance, then optimetrics and all this also supported. And there is a system level analysis also, where you can do time domain, frequency domain, as well as mixed domain. So when it will mixed domain, it includes both time and frequency domain. So this is just few examples of RFID. So nowadays people talk about IoT and RFID and all. So in Ansys can be used to completely model and design the RFID. Okay, so this is few like case studies kind of thing. So some of our customer, which anyways I can't name, they have designed the RFID transporter using our HFSS. So the operating frequency of this transport, the basically this antenna transponder antenna is 920 megahertz. And the input impedance is 50 megahertz. The polarization is circular polarized. the return loss obtained was minus 15 dB. So again, this is one example of transponder antenna design in HFSS. And these are some of the results. This is the return loss, and this is the 3D far field pattern. This is the radiation pattern. In 2D, we also call it polar plot. This is the left-handed and right-handed circular polarization has been done. This is just one case study of the transponder antenna. And some of the simulations that HFSS, like high-end simulations, in HFSS are human exposure. So there is a body known as FCC that tells up to what limit some device can radiate in terms of power density. It has to be measured, right? So this table one, is the limiting table. We call this one as a limit table. It tells that how much electric and magnetic field in how much frequency range some particular device can transmit. So as per the table, this criteria has to be met by a mobile phone companies and all. So we also call it SCR simulation, specific absorption ratio simulation, right? So this is one example of that. So in here, there is a power density for frequencies between 1.5 gigahertz and 100 gigahertz. So this kind of testing can be done. This is another example of human device interaction. So whenever I tend to keep my mobile phone in my hand, and if I if I tend to move my fingers, then definitely my antenna performance also will be different, right? As you can see here, the antenna radiation pattern is varying. So this kind of studies also can be done, like return loss versus not frequency. At one frequency, what is the return loss versus my finger position? This kind of studies also can be done. And again, you can do the power density evaluation for FCC certifications and all. And this is another example of radiated emission testing, CISPA 25 standard. So left hand side is the actual CISPA 25 standard. Right hand side is our Ansys test band model. As you can see, as per the standard, same has been modeled. We have done, so we also call it pre-compliance testing. So this kind of pre-compliance testing can be done. This is one more example of radiated emission. So there is a microwave oven. As you can see, whenever the microwave oven is facing towards the antenna, the peak is increasing, volts per meter. The electric field is increasing. Whenever the microwave oven face is opposite to that of antenna, it is decreasing. So this kind of studies also can be done. This is another example of radiated emission study. So this is the actual anechoic chamber. There is a microwave oven here, and there is a source inside the microwave oven. So whatever electric and magnetic field is coming out of this oven, same has been captured by the antenna. So I mean, that's all from my side. I mean, in 25 minutes, it was really difficult for me to cover everything, because this is a very big area, very big application. So if anybody has, or if anybody wants to know on any particular application, you can ask me, or you can write to our team. We will do a dedicated session in any of this technology. We don't have any problem. But in this session, if you have any questions, if you please feel free to unmute yourself or ask, or you can also type it in the chat column. We will be happy to answer that. Thanks for your time.
Thank you, Mr. Sivara or Hara, if I may call you, and Sapao, Mr. Sama, for the presentations. Both presentations were equally excellent. In terms of applications of the Ansys Maxwell and HFSS software, it was very wide range and impressive. Many applications and with really functional features and capabilities. Okay, I'll ask the audience and participants if they have any questions, because we've come to the end of the presentation sessions. And then we can take it from there. Oke, silakan Bapak-Bapak, Ibu-Ibu. Setelah kita menyimak presentasi tadi, dua presentasi yang cukup menarik ya, berbeda di bidang masing-masing. Memang yang masih berkaitan, tapi satu di frekuensi rendah dan satu lagi di frekuensi tinggi. Mesin-mesin yang termasuk dalam kedua bidang tersebut juga cukup berbeda ya. Saya sendiri bukan dari bidang elektronik tersebut, Jadi silakan Bapak, Ibu-ibu, kalau mau bertanya dalam bahasa Inggris boleh langsung aja, atau dalam bahasa Indonesia saya akan berusaha untuk membuat translasinya kepada beliau-beliau tadi yang presentasi. Oke, silakan. Nampaknya kalau di chat room coba kita lihat apakah ada yang sudah bertanya. It seems a bit quieter here. So maybe I'll kick off with a question for Hara.
Yes, Eddie.
We've seen the capabilities of Ansys Maxwell when it comes to designing an electric motor, for example, because that's the mega trend right now, right, with electric vehicle and all that. What do you think, in your opinion, are the most important outputs when it comes to designing an electric motor? This is a very general question, right? Can you give some insights into how to also optimize what sort of parameters in order to get the best outputs possible? Thank you.
Yeah, so I think the question is more generic, but still, so basically, when you are designing a motor, okay, am I audible?
Yes. Go ahead. Yeah.
Okay. Yes,
Audio
fine.
is fine.
Yeah. So basically, when somebody are designing a motor, obviously the requirement would be on the torque side. What would be the torque rating and what would be the power rating of the machines? And the constraints would be basically the size limitations. Means, for example, if you take a electric vehicle, okay, so they have certain space. Within that space, you have to accommodate your motor. So at the same time, you have to meet your requirements, like it might be the continuous torque speed requirements or a peak torque speed requirements. Okay, so basically these two things are the major things. Okay, when you are designing a motor for a EV, for example, okay, it varies for different applications. Okay, if it is a consumer appliances, there it is a different phenomena. If you are a EV, there is a different phenomena. If it is an industrial application, it's a different phenomena. It depends on what kind of applications you are working. Okay, so if you take a EV, this would be the requirement, like what would be the peak torque speed requirements and the continuous torque speed requirements, and what is the efficiency, and what are the current density limits. So these are the requirements. So to be in that phase, okay, they will vary couple of parameters in the designing phase itself. Okay, like if you take the magnetic thickness or a tooth width or a pole tooth width. Okay, so there are couple of names you can say. Okay, there are a lot many parameters, might be winding number of turns, it might be, or the kind of material you are choosing for that. Okay, all these are. So these kind of parameters can be parameterized, can be taken as a variable, and you can give it as a parameter, and that out of that parameters, for example, if you take a magnetic thickness, if you are not pretty sure on the magnetic thickness, you can take that as a variable from 3 mm to certain 5 mm. So out of these 3 mm to 5 mm, okay, it can suggest you the best optimized, the operating point, which one would be the most suitable for your requirement. So when you say 5 Newton meter is your requirement, so it will tell you that, okay, for the 5 Newton meter torque requirement, this much magnetic thickness would be the best suitable. Okay, so you can take any number of parameters, there is no limitation. You can take any number of parameters, and that can be integrated to our optimizers called OptiSline. Okay, it can give you the best designs out of all your variations. So, but that is a rough idea. But if you need more on that, yes, there is a dedicated sessions, as Safal mentioned, that it cannot be addressed in a single session. That's for sure. Yes, I think Eddie, you are on mute. I can't hear you. Hello, Eddie. I think you are on mute, Eddie. Could you please unmute yourself? Yes.
Yeah, sorry. Very detailed answer. Thank you, Hara, for the your opinions on my questions. That was a very insightful as well. Okay, I think we got a question from Pak Budi Utama, which I'll try to translate. I think this is more for Saval. The translation is like this. Is there a program that you can use to design the exposure of electromagnetic field that is caused by the high voltage 500 kilo kV to around 50 hertz in the transmission lines, for example, in a population area or something like that, in three-dimensional. Yeah.
Yeah. So when I said, our tool is a full wave solver, so it is solving in 3 dimension only. So when I tell, our tool is giving the electric and magnetic field, it is giving me Ex, Ey, as well as Ez. The magnetic field also, it is giving me Hx, Hy, and Hz also. So it is a full wave solver, and yes, it can easily, like in a transmission line. So what will happen to the transmission line? So if there is a very, high voltage transmission line, then that energy would be dissipated out as a heat. That is one loss. And another loss is if there is a adjacent transmission line near to that transmission line, some energy would couple to the adjacent transmission line. And there is another loss also, that is known as electromagnetic losses. So the energy flowing in a transmission line would radiate out as an electric and magnetic field. So that can be studied in our HFSS, and you can always, see the electric and magnetic field in complete 3D environment. So yes, it is possible.
Okay, thank you for the answer.
I think just I want to add one point here. As Safal mentioned that, it depends on the application or the kind of analysis you are looking for. Okay, this kind of things can also be simulated in Maxwell also. Okay, but as Safal mentioned, what exactly you are looking out of that particular application. Okay, whether you are looking for a radiated fields or whether you are looking for only the losses in that. Okay, it depends on the applications.
Yep, understood. I think the question is still also very generic, so we can't delve into it too much. We can take it, jadi Pak Budi Utama mungkin tadi udah dijawab ya, cukup jelas. Memang bisa, itu nanti tergantung apa yang hasil yang mau dicari itu. Yeah. Mungkin untuk lengkap magnetic field yang ditimbulkan, apakah nanti mau dihitung radiasinya dari magnetic field tersebut, atau energy loss-nya juga bisa di ketiga arah, Ex, Y, Z, ya kan? Jadi kira-kira begitu jawabannya, Pak. Intinya bisa sekali, itu sangat masuk ke dalam kemampuan HFSS maupun sedikit ke Maxwell juga nanti bisa dilakukan juga gitu, Pak.
Oke. Saya titip sedikit, Pak Edi.
Baik, Pak.
Ya. Seandainya kita mempunyai atau Ansys mempunyai kemampuan ke arah sana, saya sangat tertarik sekali. Kemudian mungkin di mana paket program tersebut tersedia, mungkin saya bisa lebih banyak berbicara. Yang saya concern itu cuma satu, Pak Edi. Medan listrik yang ditimbulkan oleh saluran transmisi 500 kP dengan frekuensi 50 Hz. Itu saja dulu. Ya. Nanti bahwasanya energinya nanti saya bisa melanjutkan sendiri mungkin ya. Energi atau lossesnya juga bisa kita cari sendiri.
Bisa. Baik.
Saya perlu cuma paparannya, Pak. Paparan visualisasi 3 dimensinya di jaringan itu ke permukaan bumi itu, Pak. Jadi tiangnya itu yang tinggi itu, Pak ya. Dia memaparkan medan listrik di permukaan bumi. Nah itu, yang di permukaan bumi itu saya menginginkan visualisasinya 3 dimensi. Ya, itu saja.
Oke, Pak. Coba saya
kalau ada, tolong saya di email, Pak ya. Terima kasih sekali atas perhatiannya.
Nanti kita akan jawab secara offline aja, Pak Budi.
Oke, terima kasih Pak Edi.
Sama-sama, Pak. Mari. Itu saya rasa bisa nanti untuk detailnya dan teknisnya itu seperti apa akan kita follow up lagi Pak ya. Terima kasih. Okay, next question is, can Ansys simulate the cogging force in linear induction model? This probably is for Hara. Okay.
Yes, yes. Yeah, you can able to simulate those things. Whether it is a rotating motion or a linear motion, you can able to simulate those things. And the cogging force, yes, can be predicted here. Okay.
Mm-hmm.
Yeah, that's a simple answer. Whether it can be simulated or not means yes, it can be simulated. Okay. That's why I have mentioned Ansys Maxwell is a generic electromagnetic solvers. Either you can take electrical motor in the rotating side, okay, or on the linear motion side. Or if you take other applications which are similar to this, a kind of actuators where you want to see the linear motion. Okay, of course, there is a single coil there in the actuators. Here you might have multiple amount of coils in the slots.
Okay, so in 3D as well, the follow-up question.
Yes, you can able to do it in 3D and 2D as well. Okay.
Mm-hmm. Okay, no problem. Semoga itu udah menjawab ya Pak Agus Koiron pertanyaannya. Gimana Pak?
Oke, terima kasih.
Apakah udah menjawab? Oke, terima kasih Pak. Selamat datang dan semoga ini bermanfaat ini.
Thank you, thank you.
Is there any more questions? Ada pertanyaan selanjutnya? Kalau enggak kita bisa follow up pertanyaan Pak Budi Utama tadi. Okay, there seems to be no more. We can follow up on the first question just now, which is can the software simulate the exposure of those high voltage 500 kV transmission lines in 50 Hertz, right? And display the magnetic field on the surface of the Earth, yeah, something like that, you know, on the surface of ground. Safal,
So
do you want to take the question? Yes.
Yeah, so that can be done, but you know, if the frequency is, let's say 50 Hertz, or if let's say frequency is very low, then you know, Maxwell is the right solution. It is a low frequency application. So HFSS, you know, works better if the frequency is very high. So above, you know, 1 megahertz, it is HFSS. If it is below, like if kind of frequency you are mentioning, in that frequency, definitely yes, surface electromagnetic field can be analyzed.
Yes,
but you have to use Maxwell, not HFSS.
Yes. Okay, sure. Yeah.
Yes, Eddie,
Jadi Pak Budi tadi udah dijawab
So,
ya.
Hara, you want to add something?
Yes, yes. Yeah, I just want to talk a bit on that question actually. So, Eddie, if I'm not wrong, does this question is related to the Earth's magnetic field on that particular transmission lines?
Yes, yes.
Yes, if that is the case, yes, we can able to create that environment. We have certain boundary conditions where you can model this Earth's magnetic field. Basically, as you know that it's a kind of a permanent magnet also. Okay, Earth is also kind of a permanent magnet. So that can also be modeled by using the boundary conditions. Okay, we have certain boundaries where you can model the tangential H fields or a normal H fields. But you should have a rough idea on what would be the Earth's magnetic field. Okay, that has to be, you know, you should know about those things. But you can model those boundaries in our solvers.
Yep. Okay. Yep. My apologies. It should have been directed to you because it's low frequency, 50 Hertz. Okay, Pak Budi tadi udah dijawab. Jawabannya itu bisa sekali, Pak. Mau magnet field atau electromagnetic atau electrical field juga bisa.
Electric field, oke.
Ya, elektrik atau magnetic juga bisa.
Oke, boleh.
Itu software yang cocok untuk melakukan itu semua adalah Ansys Maxwell.
Ansys Maxwell ya.
Maxwell karena dia itu low frequency ya 50 Hz meskipun tegangannya tinggi 500 kV tapi masih termasuk dalam ranah
frekuensi rendah.
Frekuensinya rendah gitu Pak.
Iya.
Jadi jawabannya bisa sekali Pak. Nanti kita bisa diskusi lebih lanjut untuk ketertarikan Pak Budi Utama untuk mengetahui lebih jauh gitu. Oke.
Oke, terima kasih.
Terima kasih Pak Budi. Mari
diskusi lebih lanjutnya. Terima kasih Pak Edi, selamat pagi.
Sama-sama Pak Budi. Okay, is there any more questions on this, on the presentation, so on the topics of low frequency, high frequency, electromagnetic. Okay, we got another question from Pak Dovir. Can Ansys transform the electromagnetic field into electric circuit model? Okay, which one is this, Mr. Safal or Hara?
Yes, it's a generic. Okay, it will work for both low frequency as well as high frequency, if I'm not wrong.
Yes.
See, here actually, if you take any application, can be represented into a 1D model. Okay, but we need to understand key whether you are looking for a direct integration. Okay, from physics-based model to the simple lookup table, or you want to just compute the components, like it might be the resistive component and inductive component of that particular application, and you want to model that in the system level solvers. Okay, there is two approaches. So automatic, I don't think it can directly create a circuit for us, but you can get the complete parameters for that particular model. If you take a motor, then that can be also represented in the form of a 1D, where you will get the resistive networks and inductive form of that. Okay, and that can be represented in the 1D platform. Okay, but apart from that, Ansys can offer you this reduced order model technology. Means you will take this model, physics-based model, and that will be you will characterize that model for a different operating points, and that model can be integrated in the system level solvers. Okay, so for that particular model, you can give your excitations, whatever the excitations you want to give it, and that can work as a simple it's a kind of a 1D platform only. Okay, there you will not feel the time delay or anything. Okay, you will get the same approach whatever you are feeling. The only thing is you can also consider the physics in that. Instead of completely working on a 1D model, you can also use the physics based approach, but that is a shortcut for that. Okay,
What is the shortcut?
The shortcut, that's what I'm telling. Like, instead of creating that particular resistive or inductive network on your own, you can create that particular component, reduced order model component, and that component you can directly
need to
use
create
it.
the complete 3D model of it first before you change it into a reduced order model, just to simplify it and make it light and easier to run?
Sorry, I didn't get your idea. Like, you are asking that, do we need to create the 3D model?
Yeah.
That's what your question? Yes, obviously. So if you need to understand the physics of that particular component, you have to create the 3D model, and that has to be characterized first.
That's right. Yeah.
We call that as a equivalent circuit extracted model. Okay. So that component will be directly linked to the system level solvers. And there you can able to excite that particular component, whatever the motor component you feel it as. Okay.
That's right. Because if you just attach it with the complete 3D model, it'll be too loaded, for system level simulation. Yeah. Okay. I think there's another question from Pak Budi again. If the electric field on extremely low frequency. Oh, yeah, okay. We'll follow up with Pak Budi Utama. He's already given his email address. He'd like to know more about this sort of simulation. Maybe he's involved in this high transmission exposure or the radiation field for electric and magnetic as well. Okay, no problems there. Thank you, Pak Budi Utama.
Ya, terima kasih.
Sama-sama, Pak. Okay, one more question. I think is from myself. I was interested in the adaptive meshing capability of HFSS. Could you tell me a little bit about the types of mesh used there? Is it a hexahedral, tetra, or polyhedral? A bit like Ansys Learn, something like that. Because I can see only tetrahedral.
Yeah. So there is only one kind of mesh in 3D FEM in HFSS. That is tetrahedral mesh. Okay. Yeah. So when you want to solve any structure in HFSS, the first step is to divide that structure into small segments. That process is known as meshing. Okay.
Yeah, understood.
Now each segment is a mesh, and each mesh is a tetrahedral. So when I tell mesh in HFSS, I'm telling tetrahedral only.
I see.
Okay. And now being a electromagnetic engineer, I don't know, right, how many mesh I might need. It becomes very difficult for a user engineer sometimes to define the mesh. So that's why what HFSS does. So when you give the frequency to HFSS, so from the frequency you'll get the lambda, right? F equals to C by lambda. So the initial lambda you'll get. Frequency user has to give. Now when you give the frequency to HFSS, then the lambda would be derived, and as per the lambda, initial size of the tetrahedral would be decided as per the lambda. Now it will do the meshing in one step. It will calculate the electromagnetic field, and there is an algorithm known as error vector estimation. It will automatically see the error in the electromagnetic fields. So whenever error is more, it will go back to that particular area and it will increase the mesh. This process keeps on happening until best mesh is generated. This process is known as automated mesh refinement process.
Yeah, a bit like Ansys Flow as well when it comes to dynamic and adaptive mesh sort of function.
Yeah.
Okay.
Yeah.
Yes. Any other questions? Ada pertanyaan lain dari Bapak, Ibu-Ibu sebelum kita tutup sesi ini? Karena jam udah menunjukkan 20 menit lewat jam 1, udah sekitar 15 menit overtime. Tidak ada lagi. Jadi saya akan menampilkan itu slide yang menunjuk. Silakan di halaman untuk mengisi kehadiran supaya kita bisa mengirimkan sertifikat kehadiran. Oke. Oke, jadi selamat siang untuk semua peserta, Bapak, Ibu-Ibu yang saya hormati, saudara-saudari, para profesional, rekan-rekan mahasiswa-mahasiswi semua. Dengan ini saya menutup sesi discussion forum 6 yang kita adakan di antara Optimax dan KFM kerjasama membawakan SS di sesi kali ini yang menghadirkan pembicara-pembicara KFM dari India yang mempunyai keahlian di bidang masing-masing. Oke, salam. Mr. Sama, Mr. Sivala, I have already closed the sessions.
Okay. Thank you.
The time is up, and we are about 20 minutes past. I'm just letting the screen on for them to, scan the code so they can fill out the form where the attendance form, so we can collect the data and send them the certificate of completion. Okay. Thanks guys for your support and help in making this happen. I think we got quite a few participants. Hopefully we can do this in the future again, delving into a bit more specific in certain areas and application of those software. Okay.
Thank you.
Thank you. Bye-bye. Take care and keep safe.
See you. Have a good day.
You too.